Well, hello everyone, and we have some pretty groovy stuff here. In your entire math career, I bet they've never asked you to make a problem from scratch. You've always been solving problems. You've always been on the other end of it. You haven't been on the instructor end of it, making problems. And really, that's what's going on here today. They're asking us to create a quadratic equation that has the solutions -11 and -1. Now, at this point in time, I want to draw your attention to this video that I created and showed you earlier in the course. I call it the total course hack. And the reason is because this hack here threads the course and holds it together. Not only Math 122 intermediate algebra, but college algebra, calculus, and trigonometry. In fact, if I was going on in math, I'd bookmark this video and watch it before I take those courses because for some reason, no one has seemed to recognize, at least none of the authors I've seen, have recognized that there's this common idea flowing through these courses. You can really wrap up and tie the material together with this sort of thinking here. And it's what I'm going to use to solve this. Now, what we're looking to do here is create some bubbles. And the technical term for this is really linear factors that when multiplied together give us a 0. And we want this first linear factor to equal 0 when x is equal to -11. And so, the thinking here is, notice if I make this plus 11 here, when I put -11 in for x, I get 0 there. And so I'm creating this equation using the principle of zero products and this idea of what makes these bubbles or linear factors go to 0. Now over here, there's two choices. It could either be +1 or it could be -1. The idea is that when we put x is equal to -1, this thing has got to go to 0. Notice it doesn't in this situation. -1 minus 1 would give us -2. But notice if I change the minus to a plus, when x is equal to -1, I do in fact get 0 there. And so what I'm doing is I'm making these linear factors or bubbles take on values of 0 exactly where I want them to be. And those values where I want them to be happen to be solutions. So that's how you do this. And that's the idea of the total course hack. And I've been calling these things linear factors. And the reason why is if you were to rip one out and set it equal to y, it would graph as a line. So they're linear factors. And you can imagine there's probably something called quadratic factors. The MathXL problem asks us to write this in standard form. So that means ax squared plus bx plus c is equal to 0. I need to actually do these multiplications. Now, whether you're thinking is FOIL or double distribution, the idea is you're going to have 4 arrows, 4 multiplications. This first one's going to give you x squared plus 1x. And then we're going to multiply 11 times x and 11 times 1. And of course, I've got some like terms here. I'll take care of that in a second. So we get x squared plus 12x plus 11 is equal to 0. And I'd say voila, we've actually created a problem. And it happens to be a quadratic, so it's going to have 2 solutions. And we know what those solutions are. They're -11 and -1. If you were to put -11 in here, you'd get 0. If you put -1 here, you'd get 0. And so very empowering stuff, and this actually gets used quite a bit. It turns out to be a very powerful tool for more analytical algebraic stuff that follows in grad school. There's only one more thing I want to show you. Check this out. This is what I call the best online grapher. Here's the quadratic equation I just created. Notice the solutions here are -11 and -1. Now, what we had in that problem was this equal to 0. But instead of having this equal to 0, I'm setting this equal to y. So I'm getting a quadratic function which graphs as a parabola. Notice when the x values here are -11 and -1, notice that that's really the x-intercepts here where the graph crosses the x-axis at -1 and -11. So this is something that we're moving towards. We've been dealing just with equations and not their graphs, but I wanted to show you how this all ties together now. Here is another one, and I think you could tell me that the 2 solutions here are 20 and 20. And so, you might wonder, well, how is that going to graph? It's not going to have 2 x-intercepts, it's just going to have 1. And so what will that look like? It's going to be a parabola. Let me uncheck this and let me hit the graph. And see, there it is right there. When you have double root, the vertex of the parabola is exactly on the x-axis. So we have a situation where the parabola cuts the x-axis in 2 places. We have it where the vertex of the parabola, the turning point, is exactly on the x-axis. How about a situation where it doesn't touch the x-axis at all? And that's the solution, and I couldn't factor it here because I need to use imaginary numbers, and this graphing calculator doesn't allow the use of I. Let me just show you how that graphs. And as you can see, it doesn't cross the x-axis at all. And so here's a situation where we have two real roots. Here's a situation where we have one real root duplicated. And here's a situation where we don't have any real roots, but we do have solutions. They just happen to be imaginary. So lots of stuff is going on in this first problem, and I hope that helps. Let's get on to the second problem.